Combustion! It makes us think of big fires and explosions, but did you know this process powers millions of vehicles every day? Combustion is the heart of most engines, driving cars, trucks, motorcycles, and more. Without it, our world would be very different. Imagine a world without cars, buses, or airplanes. Combustion makes these machines move. It turns fuel into energy, moving us forward. Understanding combustion helps us understand engines. It's not magic, but a mix of elements working together. We'll explain the science behind combustion and its role in powering our world. Get ready to explore how controlled explosions make things possible. Combustion might seem complicated, but it's actually quite simple. Think of it like a three-legged stool. Each leg is important. The three legs are fuel, oxygen, and heat. Fuel, like gasoline or diesel, gives the energy. It's what burns to release energy. Oxygen from the air helps the fuel burn. It mixes with the fuel to make it burn. Heat is the spark that starts everything. It breaks down the fuel to start the burning. Like a stool needs three legs, combustion needs fuel, oxygen, and heat. If one is missing, it won't work. Here's the cool part. Combustion isn't just burning fuel, it's about using the energy from that process. When fuel, oxygen, and heat mix in an engine, they create a controlled explosion. This explosion makes a lot of energy as heat and expanding gases. This is where the magic happens. Engines are designed to capture this energy and turn it into mechanical work. The expanding gases push pistons, which rotate a crankshaft. This rotation powers your car's wheels. Think about it. The controlled explosions happening thousands of times per minute in your engine move you forward. It's amazing how we use fire to power our modern world. Not all fuels are the same. Just like people eat different foods, engines need different fuels. The most common fuels are gasoline and diesel. Gasoline burns easily and evaporates quickly. It's great for small engines because it lights up fast. Diesel is thicker and has more energy. It's used in big engines like trucks and buses, but there's more. New fuels like ethanol and biodiesel are also being used. These come from renewable sources and can help reduce pollution. Section 5, air, the unsung hero of combustion. We've talked about fuel, but what about air? Specifically, the oxygen in the air. Without oxygen, combustion can't happen. It's like baking a cake without flour, impossible. Engines need fresh air to keep running. This is where the air intake system comes in. It pulls in air, filters it, and sends it to the engine. But it's not just about getting air in, it's about the right amount. Too little air and the fuel won't burn well, causing pollution. Too much air and the engine runs less efficiently. Section 6, spark plugs, igniting the engine's fury. We have the fuel and the air, now we need the spark. This is where spark plugs come in. These small parts ignite the air-fuel mixture in the engine. Think of spark plugs as tiny lightning bolts, creating an electrical arc between 2 points. This arc gets extremely hot, providing the heat needed to start combustion. Spark plugs are placed in the cylinder head, sticking into the combustion chamber. When the piston compresses the air-fuel mixture, the spark plug fires, causing the explosion that powers the engine. Section 7, the art of timing when spark meets fuel. Timing is crucial for combustion. The exact moment the spark plug fires affects engine performance and emissions. This is called ignition timing. Ignition timing is when the spark plug ignites the air-fuel mixture. If the timing is off, the engine won't run well. If the spark is too early, it fights the piston moving up. This causes knocking and less power. If the spark is too late, fuel isn't fully burned, wasting fuel and increasing emissions. Section 8, from explosion to motion, how combustion powers your ride. We've talked about what makes combustion happen and the spark that starts it. Now let's see how this explosion makes your car move. Remember those expanding gases? When the air-fuel mixture ignites, it expands quickly, creating a lot of pressure inside the cylinder. This pressure pushes the piston down. The piston is connected to a crankshaft by a rod. As the piston moves down, it turns the crankshaft. This turning force goes through gears and shafts to the wheels, making your car move. Section 9. Mastering combustion, the quest for efficiency and power. Controlling how fuel burns in an engine is key to making it better. By adjusting the air and fuel mix, engineers can make engines run better, use less fuel, and pollute less. This is where sensors and engine management systems help. Modern engines have sensors that check air, fuel, and exhaust gases. These sensors send information to the engine control unit, or ECU, which acts like the engine's brain. The ECU adjusts things like ignition and fuel injection in real time to keep the engine running its best. This constant adjustment helps modern engines be powerful and efficient.